Hello and welcome to the Certified Ethical Hacker Study Guide. In this video, we will discuss Chapter 8.5, Linux OS Vulnerabilities. Please like, subscribe, and hit the notification bell. Now let's scream into the first topic after this short break. Like any OS, Linux can be made more secure if users are aware of its vulnerabilities and keep current on new releases and fixes. It's assumed you have some experience working with the *Nix OS. So the basics of the Linux OS and file system aren't covered in this module. Many Linux versions are available, with differences ranging from slight to major. For example, Red Hat and Fedora Linux use the yum command to update and manage RPM. Red Hat Package Manager packages, and Ubuntu, Debian, and Kali Linux use the apt-get command to update and manage Debian packages. Whatever Linux version you use, you must understand the basics, such as run control and service configuration, directory structure, file system, basic shell commands and scripting, and package management. If you're unfamiliar with these *Nix basics, spend time reviewing them. One of the quickest ways security testers can make a poor impression on clients is to show a lack of knowledge about the systems they're testing. A typical Linux distribution has thousands of packages developed by many contributors around the world. With such diverse sources of code, it's inevitable that some code will have flaws that are sometimes discovered only after they have been incorporated in the final product. Too many network administrators believe Windows is easier to attack and view *Nix OS as inherently more secure. Security professionals must understand that making these assumptions can be dangerous because all OSs have vulnerabilities. When conducting a security test on systems running Linux, you should follow the same rules you would for any OS. Now let's fall into the next topic right after this short break. Users expect to share resources over a network, regardless of the OS used, and companies have discovered that users no longer tolerate proprietary systems that can't coexist in a network. To address the issue of interoperability, a group of programmers created Samba, www.samba.org, in 1992 as an open-source implementation of CIFS. With Samba, Unix servers can share resources with Windows clients, and Windows clients can access a Unix computer. Samba has been ported to non-*Nix systems too, including OpenVMS, NetWare, and Amiga OS. At the time of this writing, security professionals should have a basic knowledge of SMB and Samba because many companies have a mixed environment of Windows and Unix systems. To access a Nix computers to access Windows resources, Samba is often used. It's not a hacking tool. This product was designed to enable Nix resources are Windows resources. A Nix computer. Most new versions of Linux include Samba as an optional package, so you don't need to download, install, and compile it. Now let's dive into the next topic, right after this short break. Tools for identifying Linux vulnerabilities. Visiting the CVE website is a good first step in discovering possible avenues attackers might take to break into a Linux system. Table 8.3 lists a small portion of the CVEs and CANs found when searching on the keyword Linux. To give you an idea of the multitude of Linux vulnerabilities, more than 500 entries were found. Many of these vulnerabilities can no longer be exploited on systems that have been updated. Now let's stare on into the next topic right after this short break. CVE 2021 36148. A buffer overflow in the function DMR_free_IRT in the file hypervisor /arch/x86/VTD. C allows the attacker to corrupt memory. CVE 2021 35039. A vulnerability was found in Linux kernel up to version 5.12.13, affecting the function init _module of the file kernel/module C. The manipulation with an unknown input leads to a weak authentication vulnerability. CVE 2000 19.14.896. A heap-based buffer overflow vulnerability was found in the Linux kernel, version kernel 2, 6.32, in Marvel Wi-Fi chip driver. A remote attacker could cause a denial of service, system crash, or possibly execute arbitrary code when the LBS_IBSS_join_existing function is called after a stay connects to an AP. Now let's drop on into the next topic right after this short break. You can use CVE information when testing Linux computers for known vulnerabilities. Security testers should review the CVE and can information carefully to ensure that a system doesn't have any vulnerabilities listed on the CVE website and has been updated. You can use CVE information when testing Linux computers for known vulnerabilities. Security testers should review the CVE and can information carefully to ensure that a system doesn't have any vulnerabilities listed on the CVE website and has been updated. You have learned how tools such as OpenVAS, aka Greenbone Security Assistant, can enumerate multiple OSs. Using enumeration tools, a security tester can do the following. Identify a computer on the network by using port scanning and zone transfers. Identify the OS the computer is using by conducting port scanning and enumeration. Identify via enumeration any logon accounts and passwords configured on the computer. Learn the names of shared folders by using enumeration. Identify services running on the computer. Now let's fire into the next topic right after this short break. One method of attacking networks remotely is installing Trojan programs that record keystrokes and other processes without users' knowledge. Trojans can be installed after users click an attachment to an email message, or while users download a file from the internet thinking it's a patch or a security fix for the OS they're running. Because the web server logs the IP address of all visitors, when users download a file from the internet, attackers then know the IP address of the person who downloaded the Trojan. When installed on a computer, a Trojan can carry out many actions. Sometimes it advertises enumerated victim information to a specific port, so the attacker needs to monitor or connect to that port to gather the information. Other times, a Trojan can be programmed to automatically connect back to an attacker machine. Most Trojans perform one or more of the following functions. Allow remote administration of the attacked system. Create a hidden file server on the attacked computer so that files can be uploaded and downloaded without the user's knowledge. Steal passwords and enumerate installed software from the attacked system and send them to the attacker. Log all keystrokes a user enters and email the results to the attacker or store them in a hidden file the attacker can access remotely. Encrypt all of the user's files and hold them ransom. Destroy all of the data on a victim system. Now let's fire into the next topic right after this short break. Linux Trojan programs are sometimes disguised as legitimate programs such as DF or TAR, but contain program code that can wipe out file systems on a Linux computer or allow for remote administration. Trojans are more difficult to detect today because programmers developed them to make legitimate calls on outbound ports that an IDS or a firewall wouldn't normally detect. Because the generated traffic looks just like normal network traffic, the Trojan is difficult to detect. For example, a Trojan called Harry makes HTTPS post requests over port 443. These requests are not unusual on a network. The web server could then be configured to issue commands that are carried out on a Linux computer. The HTTPS traffic appears to be normal network traffic, but the commands sent from the web server could contain other commands requesting that the attacked computer download or copy sensitive files to a remote web server. Some recent Trojans are controlled by encoded or even encrypted commands that attackers post on social networking websites. Someone monitoring network traffic coming from these infected systems. The activity might look like a normal user browsing through Facebook or Twitter, for example. Protecting Linux computers against Trojans that IT professionals have already identified is easier. For example, the linux.backdoor.kiten Trojan logs on to an Internet Relay Chat (IRC) site automatically and waits for commands from the attacker, controller. Linux antivirus software from McAfee, Sophos, and Symantec can detect this backdoor Trojan. Even more dangerous are rootkits containing Trojan binary programs ready to be installed by an intruder who has gained root access to a system. Attackers can then hide the tools they use to perform further attacks on the system and have access to backdoor programs. If you find this video useful, please hit the like button, leave a comment, and subscribe to the channel. To see more videos like this, please click in the rectangle in the middle of your screen. To see other videos from this channel, please click the circle on the bottom right. Thanks for watching. See you on the next one.